Hey everybody, welcome to Algebra 1, Section 2.5, Literal Equations. What are literal equations? It's not all this chapter we have literally been doing equations. No, what we mean by literal equations is kind of like literature that has a lot of letters. Literal equations have lots of letters. And instead of trying to figure out what x is, which is the normal goal of an equation, with literal equations, you're trying to just rearrange the formula in order to get one specific variable by itself. So by the end of this lesson, you should be able to isolate one of many variables. You should also be able to isolate a variable and evaluate a formula. So let's do a couple of examples. All right, so let's start off with a regular equation like what's normal for us to see. So here I've got x minus 7 equals 8. So over here, to get x all by itself, we would add 7 to both sides. And the plus 7 and the minus 7 would cancel each other out. And you'd get x equals 15. So that's the goal of most equations, is to figure out what the variable is. Well, let's take a look at this equation over here. It says solve for x minus b equals a. Now in this case, our goal is to get x all by itself. But we're not going to get a number answer like x equals 15. What we're going to do is we're going to follow the exact same steps as what we did over here. In order to get x all by itself, we added 7 to both sides. So over here, to get x all by itself, I'm going to add b to both sides. So in that case, the minus b and the plus b cancel each other out. So now I have x by itself. But for the answer, like we're used to seeing a number, just a single number. Over here, what is a plus b? I have no idea what a plus b is. So we're going to just leave it as a plus b. So you can see that everything that was in the problem is still in the answer. It's just rearranged to get x all by itself. Let's take a look at this example here. It says solve for k. Negative 3k equals m. Well, let's take a look at this other problem and see what steps we use to solve that, and then we'll use similar steps to solve for k. So over here, in order to get x all by itself, I'm going to divide by 4. So those 4's cancel out, and I get x equals negative 12 divided by 4 is negative 3. Let's use those exact same steps over here. In order to get k all by itself, I'm going to divide by negative 3. And then the negative 3's cancel out, so I get k equals m over negative 3. Now, I don't know what m divided by negative 3 is, so that's just going to be my final answer. M. It doesn't matter where you put that negative. It can be on the m, it can be in front of the fraction, it can be on the 3. It all means the same. But the important part is I got k all by itself. And again, notice everything that was in the original equation is in the answer, just rearranged. Let's try this one. Solve for g. Well, what else is hanging out with the g? There's the a and the e. What are the a and the e doing? They're both multiplying the g. So because they're doing the exact same thing, I can get rid of them all in the same step. I can divide by ae. Oops. And that way, ae up here and ae down there can both cancel out at the same time. So g equals 10 over ae. The answer is not pretty, but it doesn't have to be. Let's take a look at question 5 here. Solve for y. Y over 3 equals h. Well, let's do a similar problem over here. X over negative 8 equals 11. So x over negative 8 is the same thing as x divided by negative 8. So I'm going to multiply by negative 8 on both sides. So that negative 8 cancels out that negative 8, and I get x equals negative 88. Now using the same logic, let's go ahead and do this other problem. In order to get rid of that 3, I have to multiply. Oh, that's an ugly 3. That's a pretty 3. All right, I'm going to multiply both sides by 3. So that this 3 and this 3 cancel each other out. And h times 3 is just 3h. Typically, when we multiply a number and a letter, we put the number first. And that's my final answer. Let's take a look at a few more problems. Solve for b. 2a over b equals 3c. Well, if I'm going to get b all by itself, b being in the denominator is a bad place for it to be. That was a complicated sentence. So here's what I'm going to do. I don't like having that fraction there. I'm going to clear out the fraction by multiplying by what's in the denominator. Much like we did on the last problem, I'm going to multiply both sides by b. So that way this b cancels out that b, and I now have 2a equals 3cb. Or if you wanted to call it 3bc, that's fine too. So now, in order to get b all by itself, I've got this 3c hanging out with it. So I'm going to get rid of both the 3 and the c at the same time by dividing by 3c. So over here on the right-hand side, the 3's cancel out, the c's cancel out, and I'm left with b all by itself. And then 2a over 3c, I can't do anything with that. It's just going to stay 2a over 3c. And that's my final answer. Let's do another problem. This one's a little bit interesting. It's got parentheses, but we should know how to deal with that. So if you recall from our last lesson, or maybe section 2.3, in order to get rid of those parentheses, we need to distribute. So now I have 20x plus 5p equals w. Now if I want to get p all by itself, I've got to get rid of this 5. I also have to get rid of the 20x. So SADMAP tells me I need to get rid of that 20x first, so I'm not going to divide by 20. I'm going to subtract the whole thing. Subtract 20 and x together. So this positive 20x cancels out that minus 20x. And I get 5p equals, ooh, that's a mess, w minus 20x. I can't do anything with that. It stays w minus 20x. Last thing to do to get p all by itself is divide by 5. So those 5's cancel out. And my final answer here is not pretty at all. But p equals w minus 20x over 5. Now you might say, well, can't the 20 and the 5 reduce? You could, and if you wanted to write it as p equals w over 5 minus 4x, that would work too. I would count that as an answer. But I'm also fine if you just leave it as one big fraction. Your choice. Let's try this example. Again, we've worked with a parenthesis before. This time we have a fraction in front of it. Shouldn't really change much of anything. I'm going to distribute the 1/2. Half of 4a is 2a. Half of 10b is 5b equals c. I'm trying to get b all by itself, so I need to get rid of the 2a. And I need to get rid of the 5, I'll get rid of the 2a first. Since it's a positive 2a, I'll subtract 2a. So now I have 5b equals c minus 2a. Divide by 5. And my final answer is b equals c minus 2a all over 5. I think the more you practice this, the more it's going to make sense to you. I totally understand if this does not make any sense at the very beginning. But the more you do it, the better you're going to get at it. Now, one application of literal equations is formulas. We use formulas all the time in physics, chemistry, geometry. And so what we're going to do is we're going to take some very common formulas and we're going to rearrange them to get a specific letter all by itself. So on this question, solve for b, area equals 1/2 base times height. That's the formula for the area of a triangle. So how do we start getting b all by itself? First off, it's got that fraction in there. I don't like to have fractions in my stuff, so I'm going to get rid of it. How can I get rid of 1/2 in front of that variable? Well, if you recall, the way we get rid of a fraction in front of a variable is to multiply by the reciprocal. So I'm going to multiply by 2 over 1. So that way, the 2's can cancel out, the 1's cancel out, and I just have BH on that side. On the left-hand side, 2 over 1 times A, well, that's the same as 2 times A. So now I no longer have any fractions. 2A equals BH. So now let's go ahead and get B all by itself by dividing by H. And that's my final answer. 2A over H equals B. Let's talk about the circumference of a circle. C equals 2 pi r. If I want to get r all by itself, I can get rid of 2 pi, both things all in the same step. So c over 2 pi equals r. Problem done. Let's take a look at this other example here. It gives us the perimeter for a rectangle formula, and it says find W when P equals 36 and L equals 5. So you might think, oh, that's not a problem. I just plug in the 36 for P and plug in the L for 5. And you can do that and then work it out and get W all by itself. But it asks you to do similar problems 3 different times. So rather than plug it in and work it out, what if I work it out first and then plug in the numbers? So if I'm trying to find W, let's get W all by itself. Let's subtract 2L from both sides. And then to get W all by itself, let's divide by 2. So now I have P minus 2L over 2 equals W. Now the whole purpose of doing this to make this problem easier is now that I have W all by itself, now I can plug in those numbers and figure out what W is. So if I want to plug in 36 for P and 5 for L, I get 36 minus 10, which is 26. 26 divided by 2 is 13. If I plug in the 44 and the 18, 44 minus 2 times